Suppose a Utrecht University scientist wants to investigate the El Niño climate phenomenon.
We think we can understand the El Niño system better if we reconstruct events during different periods of climate history on Earth.
Obviously, he's fascinated by its impact on our planet, not only today, but also in the past. In fact, by reconstructing past El Niño events, we might learn some valuable lessons for the future. So what do you do next? You write a scientific proposal to get sediment cores from high mountain lakes in the Andes. Then you gather a multidisciplinary science team, get some funding, and fly to Ecuador for some hands-on fieldwork.
So when an El Niño event develops, essentially a large amount of heat crosses the Pacific Ocean and causes rains and floods in places like Peru and Ecuador.
What started as a single phrase in the project plan, in reality became a tough expedition, carrying heavy coring equipment along small and steep Inca trails to the top of the Andes to reach the lakes.
So every 5 to 7 years, an El Niño event comes by and the rains flood this valley, bringing in sands and clays that create a thin white layer into the sediments, the dark muds of the lake. And in this way, the history of the area accumulated in the lake for the past 15,000 years.
And after 1 week of retrieving precious mud from the Andean lakes, the team headed back home, straight into the lab, the next stage of this investigation. Back at the university, the team now faces a task of piecing together El Niño's history and past activity from the sediment samples.
Anything that helps us to get a high-resolution record of past temperature and rainfall will help. So right now we look at pollen and diatoms to read the natural archive, just like a book.
Right now, the scientists think that El Niño has always been present, but about 5,000 years ago, it became much more active. The key question is, why?
So we think that slow changes in the contrast between winter and summer push the El Niño system across a boundary, triggering new and unexpected behavior. So that change is seen across many parts of the globe, and so far is very difficult to simulate with computer models. Now, the sediments we'll study will tell us about how rapid and strong this transition really was.